Okay, we are live. Waiting for my guests to come up. I've already see Grant Gilmore has appeared. So Grant, if you'll make sure you have unmuted yourself, we can talk for a few minutes before the kids start watching. Hey Grant, how are you? I think you're muted, Grant. Let's see. There you go. Okay, we are live. Waiting for my guests to come up. I've already see Grant Gilmore has appeared. So Grant, if you'll make sure you have unmuted yourself, we can talk for a few minutes before the kids start watching. Hey Grant, how are you? I think you're muted, Grant. Let's see. There you go. Okay, we are live. Waiting for my guests to come up. I've already see Grant Gilmore has appeared. So Grant, if you'll make sure you have unmuted yourself, we can talk for a few minutes before the kids start watching. Hey Grant, how are you? I think you're muted, Grant. Grant, can you hear me?
Good morning.
There you are.
How's it going?
It's good. Is this Kyle?
This is Kyle.
Kyle, Grant's having trouble. I'm seeing him. Can you see him at the bottom? But
You can see him, but you can't hear him?
I can't hear him, and he's got his tech people, I think, working on it, but I just think he's muted.
Yeah. Grant, most likely, Grant, do you see like the microphone-looking thing? Basically, there's an options menu somewhere at the top. There's like a little video camera, a camera with arrows, which means rotate your camera, and then a microphone. Deja, you might be able to do it. Because I'm on an iPad, it's not playing nicely. I don't have all the options, but if you can click on his name, you might be able to mute and unmute him, and that might just trigger it.
Let me try. It just mutes me.
But if you click on his name,
Yeah, I'm clicking on his picture, and it still puts the mute button up on me.
okay, if you just hover over top of it, does it give you an option?
It says, yeah, it just mutes my microphone, and I'm on his picture.
Which is weird because I'm hearing you. I'm not hearing it mute your microphone.
Okay, I just muted.
Yep, you muted. So now unmute him.
Okay. Grant, can you hear me?
All right. Go into, Grant, I think it's in the upper right-hand corner of the screen. There's a little settings wheel. And you might have to find the audio control in that settings wheel.
What if he's even hearing us?
Yeah, let's try to open. Let me see if we chat to him.
Let me tweet him real quick.
Okay. And Daisha, I'll be right back. I forgot something downstairs.
Okay. Can you unmute yourself? Can you hear me, Grant? He went away, so maybe he's going to come back in.
Yeah, it's probably a good idea. Sometimes that solves it. And did you say Reed is joining us this morning as well?
He's supposed to. I sent an email and a thing, and he had said he was going to try to make it work out through a. I got a message from him, but I don't know.
Yeah. No, that'd be great.
We need to. This is.
Oh, we hear you.
Grant, we hear you.
So, I mean, with the audio, so we should probably turn the audio off with that.
Grant, can you hear me?
Hello, hello. Can you hear me?
We hear you.
Actually,
so maybe
does this not have speakers? Oh, I can get headphones.
Probably a good idea.
So he's watching it on YouTube, and there's like a 15-second delay. He's supposed to. I sent an email and a thing, and he had said he was going to try to make it work out through a. I got a message from him, but I don't know.
Yeah. No, that'd be great. Grant, you have a feedback?
Grant, we hear you.
You hear me? Great. We had to get a microphone.
Yeah. We also hear Daisha. We're getting a feedback
Grant,
loop.
can you hear me?
Hello, hello. Can you hear me?
We hear you.
So maybe
Does this not have speakers? Oh, I can get headphones.
Grant, so he's watching it on YouTube, and there's like a 15-second delay. He's supposed to. I sent an email and a thing, and he had said he was going to try to make it work out through a. I got a message from him, but I don't know.
Yeah.
Feedback should be over now.
Kyle,
Yes.
what should I tell him to do?
I think we're good. I think he just did it. I think he got his volume, so we're good to go.
So Grant, give me a thumbs up if you hear me.
He went to go get speakers.
I think he has headphones in.
No.
Grant,
Do you have headphones in, Grant?
She started a little earlier and stuff.
We hear him loud and clear.
So yeah, same thing goes through. A lot.
Grant.
But then the other thing we've been talking to her about is, no, we won't rule anything out. Never rule anything out to figure out what's going on. But
All right. Can you hear me, Daisha?
I can hear you, Grant. Can you hear us?
Yeah, I can hear you finally.
Okay, great.
Yeah.
So thank you for turning your feed off, because it's about a 20-second delay on YouTube.
Yeah. Yeah, we realize that.
And Grant, this is Kyle Schutt. He's from Discovery Channel. You see
Hey,
him?
Kyle, how's it going? Yeah.
Grant,
Good to see you, man.
thanks.
Still waiting on Nate Johnson
Okay.
and hopefully Reed,
right.
Timmer, and because I did invite Jim too. So hang on just a second. Let me see what's happening right here.
Okay. Well, I'm still trying to work out some things because some reason the laptop speakers aren't working. So I would prefer not to have to go with these headphones, but
Yeah, it's working fine though. I don't think it's a problem. I think the students are used to seeing us on Hangouts and things with your.
yeah. Well, we're actually trying to record it from our end too. So we've got a camera crew here that's going to be trying to record. So ideally, we'd like to have some of this ambient sound from you guys instead of just my voice, because as entertaining as I am.
I understand now. I understand.
Yeah. Gosh, this is a problem.
So
But we have about 2 minutes before the
Okay.
kids are tuning in.
Speakers.
if you
All right.
unplug your headphones, it's not coming out of your computer audio.
No, it's not. Give me 1 second. I'm going to unplug my headphones, and if you guys wouldn't mind just chatting a little bit, that would be great. I'd appreciate it.
Sure. Daisha, since he needs us to chat anyway, what's just a big overview? What's the outline look like? For 30 minutes? Is that correct?
Yes. So the kids have submitted questions.
Okay.
The kids have submitted questions from the county. There's a lot of kids watching, though. I have over 2,000 that should be in. So Nate just said that he's not gotten his invite yet, but I've invited him.
It might be different. Ask him what email address, because you could be sending it to one and he needs a different one.
Okay. Let me do that right now.
And I think it said Francie joined.
Need your email. So I do have a couple of people coming in that are going to give like weather spot reports. Oh, I hear kids.
It's us. I'll mute
Okay.
us.
So go ahead and mute for a second, Francie. We're just waiting for a few other people, and then we'll pull you in. So I'm waiting for Nicholas McGuire's coming in from Kiel, England, and Annie Young is coming in from Australia. So, all right, here I've got his email. So WX, let me do this real quick. So WX4NSJ@gmail.com. So here we go. So he should come in. What am I thinking, hosting a hangout online?
Ambitious, I love it.
Coming out of my shell. All right, so Grant, are you good?
We are getting some speakers, but right now I'm just going to go from the headphones. So
Okay, so as soon as Nate pops up, I'm going to start. Thank you, Durham Public Schools in North Carolina, for waiting for us. We're getting ready to start. Thanks for, you probably enjoyed the little issues we're having right here. So
if we're not broadcasting yet, I don't know if we are, but if you're not, I don't think they will hear you just yet.
we are broadcasting.
All right, okay. Hello, everyone.
So I just invited, come on, Nate. Let's see, make sure I'm getting your thing right. WX4.
So Grant, while Daisha is doing that, you're probably the exact same thing I was thinking of, but if you have a 3.5mm jack for some...
That's what we're working on right now, trying to get some speakers to plug in. Let's see if this power.
Cool.
WX4.
All right, give me 1 second.
Just did. There's Nate. Hey Nate, how are you?
Fine, how are you?
Good. So, here's Kyle and here's Grant, and we're waiting for a few more, but we're going to go ahead and start because my kids are already in their classrooms waiting. So if you guys are okay, I'm going to go ahead and start. So welcome to our first DPS Weather Chat. My name is Daisha Jones. I work with Durham Public Schools, but my students know me as Dr. Drizzle. I'm real excited to have great guests today from all over the place. We have Nate Johnson coming to us from Raleigh, from WRAL. Oh gosh, help me, because if I say the wrong call letters, I'll get fired. So I'm going to let them really quick introduce themselves, and then we'll come back to me. So here we go. Nate, if you'll start.
All right. Well, just 1 second, I'm making a quick change here. Here we go. I am meteorologist Nate Johnson with the WRAL TV in Raleigh, although I'm coming to you from the home office in Apex, where we're attending to a little baby duty here today.
Thanks, Nate. And then Grant, if you'll go.
Yeah, I am meteorologist Grant Gilmore. I'm over here in Greensboro, North Carolina. I'm a meteorologist here. I work the evening shift, and so coming in a little bit early right now, which is why if you see some cameras moving around me, it's rare that I get up this early, so they're going to try to document it. Just this one time, I show off a little bit.
Thank you. And Kyle?
All right, good morning, everyone. My name is Kyle Shutt. I work for Discovery Education, and a whole lot of tremendous educators like Dish, and I was excited to be invited, and I definitely have some passions in weather, so hopefully I can add to the conversation this morning.
Thank you very much. And then I want to introduce my friend Francis Snyder, who's going to be a weather spotter for us. And Francis, if you'll unmute and share with us. Are you there?
We're here.
Yay! So tell us who you are.
I am here with my students, and I am the gifted educator here at Oneiko Elementary in Manatee County, Florida, where it is very warm and sunny and humid today.
Nice. Well, we are glad that you guys are all here. I'm actually trying to multitask and send something to Nate right now. Nate, it's coming in just a second.
All right.
So again, this is for our 5th grade students in Durham Public Schools, and they have been working extremely hard learning about science and weather. And we want to make sure that when they take those tests on May the 30th, that they have as much information as possible. So I have a lot of questions from them that they're going to answer. And real quick shout out, I'm broadcasting live from Creekside Elementary School, where there's over 130 5th graders right now listening to you out in their mobile unit. So Creekside, excellent job for being here. A lot of schools across the district are watching today, and we're going to have a great day. So what I'm going to do, I've never done this before, it's so exciting. So what I'm going to do is start asking some questions from my guest, and we'll let you fight over who's going to do it, but I might just click on you when you see your name. I'll put you on the spot. So we're going to start right now. So Grant, we'll start with you. And I want you to take quite a long time to answer this so that I can tweet this out to Nate real quick. So if you just please do that, make sure. So the first question is from Tiana, and she wants to know, why is it warmer on the coast of North Carolina versus the mountains?
Ooh, good one.
Ooh. What time of year? That's a great question. It really depends on what time of year for that answer. But let's see, what was the name of the student that asked that question again?
Hyena.
Well, Hyena, if you're listening, good morning to you. That's a great question. You know, you're pretty observant to even realize that. I think a lot of times, you know, some people aren't quite aware of the different weather and different climate that we have across the state. Like you said, it is cooler up in the mountains sometimes compared to the coast. The mountains, for one thing, it's actually higher in elevation, so it's higher up in the atmosphere. And in the lowest part of the atmosphere, as you climb in altitude, or as you get farther away or farther up into the sky, it actually gets cooler. So the mountains, as being a little bit higher in altitude, it's going to be a little bit cooler. And then along the coast, specifically sometimes in the winter, the ocean water helps keep the beach warmer. So that's why sometimes you will see warmer temperatures along the coast when inland it's a little bit cooler, because that ocean actually helps keep temperatures warm. But also sometimes in the summertime that ocean will cool down the temperature along the coast. So it really depends on the time of year, but just on an average day you're going to have warmer temperatures closer to the sea level compared to the temperatures higher up into the atmosphere.
Excellent. Thank you so much. Good job. So, Nate, I'm going to come to you with the next question. And does this scare you guys any, that the questions are just coming to you and you didn't get to study ahead of time?
This is fun. It's like an oral exam. This is good.
Yeah, it's a pop quiz.
And just know that we're all here to help. So if you don't know the answer, we can think, pair, share, and we can all come up with the answers together. So
I'll start Googling.
This question is from Jaden, and he wants to know, are there different types of storms dependent on the seasons? And his example is, could we have a hurricane happen in January?
Oh, that is a really good question. These are good. We're batting 2 for 2. So, Jaden, very good question. And the answer to that is yes. Different types of weather tend to be associated with different seasons. And so in the winter, we have a chance of snow. We don't really get a whole lot of snow in the summertime for obvious reasons, because it's warmer in the summer. And so different kinds of weather will help to generate different kinds of storms. Could you have a hurricane in January? storm. Can it happen? Sure, depending on where you are on the world. Around here, that's going to be really hard to do because the ocean water, like Grant was saying, even though it's warmer than the land in the wintertime, it's still too cold for hurricanes to get going. They really like that water to be 80 degrees or warmer, and we don't really have that during the wintertime, at least across enough of the Atlantic. And so that and some other things make it really hard for tropical storms and hurricanes to form in outside of the summer months. And we're actually next week, June 1st, we'll start hurricane season. And so that's when we really start to look for things to come together for hurricanes and things to form. On the flip side, we have different types of severe weather. And so sometimes, in the April and May, we'll have thunderstorms that could produce tornadoes. And then as we go into the summer months, the tornado threat really isn't that big of a deal, but then we start to worry about hail and things like that and damaging wind gusts. As we get into the fall and the wintertime again, we have to start worrying about tornadoes again. So, yeah, there are different types of storms that come with different types of seasons. Good question.
Excellent. Thank you. So, Kyle, I'm coming to you next. Now, Kyle is a friend of mine from Discovery Education Discovery Channel, and he knows a little about everything. He's sort of a jack of all trades. So I'm going to throw him a question, but his job will be also to make sure that our meteorologists are on their toes. So if he feels like he needs to give that to them to make sure they're doing their job, he will do it. But and Kyle's a new dad. Or have we had the baby yet?
Actually, we haven't. Baby was due yesterday, but we're still hanging out. So if I have to run, I'm sorry.
I was in your shoes 4 days ago, Kyle. I know exactly what you're talking about.
Congratulations.
Nice.
Thank you.
Nice. I'm not in your shoes. I've not just had a baby. Thank you very much for asking. So, Kyle, the next question is coming from Jade, or Jada, I'm sorry. And she just wants to know, why lately have we just had a lot of severe weather?
Ooh, that is a good question. Well, Jada, I've heard a couple different answers, and I wouldn't call myself an expert on any of this. I think the right phrase Daisha was trying to share with you is that I'm a jack of all trades but master of none. So I'll weigh in my ideas and my thoughts, but I would love for Grant and Nate to probably give a little bit more scientific reasoning behind it. However, I do get the chance to interact with a lot of experts, and so two people that come to mind specifically that have given me some ideas on this would be one, I work with Mark Elliott at the Weather Channel, and he was telling me that we've just had a lot more El Nino and La Nina episodes, and so that basically because the climate is changing, it's creating a lot more energy in the atmosphere. And that's similar to what I learned with some friends of mine at Polar Bears International. I had the opportunity to be up in Churchill, Manitoba, where the polar bears come to go out on the ice every fall, and they watch the ice and how the ice is freezing and shrinking and so forth. And the same thing, they're studying, those weather experts up there, more climatologists, but they're studying what those patterns show, and they've said similar things to me, that we just have a lot more energy in the atmosphere, and that's probably why. But I don't know. Nate, Grant, what do you have to say about that?
Grant, you want to jump on that one?
Well, yeah, you border on the subject of climate change, and I think, before we dive into that type of discussion, I think we have to address, just the prevalence of a smartphone in our hands, and talking about severe weather and how aware we are of it. If you go back through history, and obviously just a growth of population and more people being aware of the weather, there is just more reports of severe weather. You go back just 10 years, and you look at how many people were out storm chasing, and it has quadrupled, if not more than that, of people that are out there actually documenting tornadoes and severe weather. I mean, you look at just the last week, and you scroll through social media on Twitter or Facebook, and we have seen numerous pictures of these beautiful clouds, these tornadoes, or these other types of rotating wall clouds, and all these other huge scientific names. And I think, there has to be something that's said for just the fact that there are more people watching the weather, the more people that are documenting it. And in the end, I think that's a good thing, because there's more research that's able to be done for that. But at the same time, maybe there is something to be said for, these more frequent occurrences of El Nino or La Niñas or other types of global weather patterns that are creating more energy or more moisture in the atmosphere to produce those severe weather events, whether it's floods or hurricanes or tornadoes, or on the opposite spectrum, the lack of weather, which is what we're seeing a huge impact out in California right now, where they're seeing one of the worst droughts that they've seen in over 100 years.
Nice. Thank you very much. And Kyle, you did very well. And I love the way you used your collaboration with other people to answer that and then come back and ask someone else. So thank you. So Nate, I'm going to come to you for a second. And this is a great question. We teach our kids to myth bust, to listen to things and then prove it right or wrong, okay? And we also teach them how to track what they're doing, their progress in school. So this question is coming from Michaela, and she wants to know if you guys track your accuracy of predicting weather. And if you do, how do you do that? How do you keep up with the times that you got it right?
So it's a really good question, and we talk about meteorology as being a science. And to do science, you have to follow the scientific method. And the scientific method involves observing. It involves having a hypothesis, which is essentially what a forecast is. It's our prediction for what we think will happen. And then watching the real world and to see whether or not it actually falls into your hypothesis or not. And so if we forecast for thunderstorms this afternoon, then we'll wait to see what happens this afternoon. And if the thunderstorms happen, then we'll know that our forecast was right, our hypothesis was right. And then we need to go back and study why we were right. Same thing if we're wrong. If we forecast thunderstorms today and we don't get any, well, then clearly we thought something was going to happen that didn't happen, and we need to step back and say, well, why didn't it happen? Now, science is a beautiful thing because you can learn just as much, if not more, from when you get it wrong than when you get it right. So it's okay to make an educated guess, to make a hypothesis, and then see how it happens, see how things play out. For us at WRAL, we keep track. We have a spreadsheet. We keep all the numbers in there, and we keep have an idea of how good we are in different seasons. It might be a surprise to you, but we're actually better in the summertime overall. Not quite as good in the wintertime, but still pretty good. The fall and the spring can be tricky, depends on the year. And one of the things we've started to do this year is if you go to our WRAL Weather Facebook page, and you have to scroll all the way down kind of toward the bottom, but every time we saw a snowstorm coming or had some sort of a snow event, we actually did a report. And much like you would do for a teacher in a science class, we did a report and we looked at our forecast and how we talked about it on TV and then tried to explain in as many words as it took whether we were right or wrong and why we thought we were right or wrong. Because really, it's good to be right, not as good to be wrong, but really it doesn't matter if you can't explain why. And so what we try to do is look back at the forecast, see how things actually happen, and see what we can learn from every forecast, good or bad. So great question.
Excellent. And something that you said that we've really tried to drill into our students here in Durham Public Schools, that failure is an option and that we can learn from those things. You know, a couple of years ago, the movie Apollo 13 came out. And one of their quotes was, failure is not an option. And at that point, when they were trying to get that rocket back to Earth, that's what they needed to know, that failure was not going to be an option for them because they wanted it to happen. They wanted to save those astronauts. But we want to encourage our kids to make mistakes and learn from those mistakes and become better. I
learn more from my mistakes than I do from the things I do right. There's no question. And that doesn't mean I want to make mistakes. I want to get it right every time, but I learn more from the times that I do mess up or that I do fail. And really, if you look at a lot of the people that are very successful today, a lot of them failed a lot. But the key is they learned a lot from every different step along the way, and that's made them who they are today.
Excellent.
Okay,
So just want to remind, just want to remind you that our hashtag today is hashtag DPS Weather Chat. So teachers, if you're tweeting out, make sure you include that and include me on the tweet, and we'll get that out. And who just said Daisha?
It was Kyle. I just wanted to add one more thought because, again, I'm lucky enough to be surrounded by experts all the time. And one of my favorite expressions that I learned from some science and STEM teachers is that FAIL stands for first attempt in learning. And I love that idea. Failing is okay. It's your first attempt in learning, and it means that it's only the first try. You're going to continue to get better.
Excellent, excellent. Well, Grant, I'm coming to you next with a great question, and you better be ready because this is a question that we struggle with on our North Carolina testing. And so if you can answer this for us, we're all going to get it right, and then we'll be very happy. So here you go. They want to know if you can give them some. This is Danielle, and she wants to know if you can give her some differences between fronts and air pressure. That's going to be on the test, and they just want either to explain both of them real quick, or give them some differences.
Okay, well, that's a great question. You know, and weather is one of those things where if you relate it to like a pool of water or a swimming pool, you know, the atmosphere is really just like a liquid that's just flowing around our Earth, and so a front is literally just the barrier between two different areas of air pressure, if you can think about it that way, or different air masses. So if you have a warm air mass that typically would come out of the south, out of Mexico or out of the Gulf of Mexico, and you know, typically coming from the south, it's going to have not just warm properties, but it's also going to have moisture in that air mass. And then if you have an area, a different air mass to the north, which would be typically colder or drier, it's going to be that line right in between those two different air masses, which is going to be that front. Just kind of, you think about it also as like a battle. If you have the Confederates and then you have the Union front, it's going to be that battlefront between two different armies that are fighting against each other, and that's exactly what the atmosphere does. It's sort of battling for that space, and that line where those two air masses meet is that front. And pressure is literally just how much air is above you. And if you have a lot of air pressing down on a certain spot, then it's going to be higher pressure. If you don't have as much air above a certain spot in the atmosphere, it's going to be lower. And that's why we have a rising motion in the atmosphere with low pressure, because you don't have that higher pressure or more of that atmosphere pressing down on that point on the Earth.
I like to think about fronts and air masses kind of like your yard. Your yard is an air mass. The yard next to you is an air mass, and the fence in between, that's your front.
Yep.
Nice, nice. So, Francie, I'm going to come to you in just a minute. So if you have a student that wants to ask a question, if you can get them ready. But I'd like to go to Kyle for just a moment. And Kyle, if you can just tell us a little bit more about the polar bear thing that you've worked with in the weather, that would be great.
Sure, I'd be happy to. So each fall, we do a series of events similar to this one, where we have the opportunity to go up to Churchill and go onto the tundra, and basically there are scientists up there all fall throughout the fall, mostly October and November, because it's known as the polar bear migration capital of the world. And the reason why is because Churchill's right on kind of the south. I guess that's the southwestern side of the Hudson Bay. And so the polar bears are all coming back to the bay because they're waiting for the ice to freeze over. And once the ice freezes over, then they can go out there onto the ice and try to get some food. They haven't eaten in several months, and so they're looking for seals that pop up on the ice. So what's really interesting is that the scientists are out there in these big tundra buggies, and if you can imagine a school bus with monster truck tires on it, that's similar to what it looks like. And they're driving around on the tundra, and they're doing exactly what we're talking about. They're collecting data, temperature, the levels of the sea ice, how quickly it's forming, how slowly it's forming, things like that. And so it's a neat place to be, and it's just another opportunity to share about the weather. And more so they're talking about climate. Remember, there is a big difference there between weather and climate, and I'm sure Grant and Nate probably have some good definitions. I always think of it as climate is a series of weather patterns over a long period of time, whereas weather is what it looks like at one point in time, or at maybe one day or something like that. So they're looking more towards climate and what's going on, but it's a pretty cool experience. And if you go take a look at Polar Bears International and their website, they have a whole bunch of those archived, and you can watch, and you can even join in the fall.
Nice. So Francie Snyder, I'm going to click on you for a moment. So if you'll unmute, and if you can give us a question for one of our experts, we'll take that now.
Okay, we were trying to decide which question to ask, but Mackenzie, do you want to ask yours? These are second graders. Go ahead, Mackenzie.
How does lightning and thunder happen?
So the question is, how does lightning and thunder happen? And so I don't know which one to go to, Grant or Nate. Who wants it?
Nate, you want to take that?
Sure. So lightning happens. Lightning is electricity. Just like I'll show you. I have a light bulb here, and this is electricity. That is moving electricity or current electricity. Lightning is something called static electricity. So it doesn't move like electricity that feeds your light bulbs and your microwave and your TV and your computer, but it's basically the same thing. So what happens in a thunderstorm, you'll have all the little different raindrops and hailstones and things like that all have a little bit of an electric charge to them. And as they rub together, sort of like if you rub your hands together or rub your feet together on a cold, dry day. Yeah, I see everybody rubbing their hands together. If you do that on a cold day and sort of scuff your feet across the floor and then touch a metal doorknob, you'll get a little bit of a shock. Has that ever happened to you? You touched a doorknob and it shocked you? That's basically the same thing as lightning, but just on a much smaller scale. So inside a thunderstorm, you'll have the positive charges and the negative charges separate, and eventually essentially that separation becomes too big, and Mother Nature wants to balance everything out. And so Mother Nature does that by an electric charge. And sometimes you'll have that separation happening within the cloud, but also you have it from the bottom of the cloud down to the ground. And so if you have that separation become too large, that's when you get a bolt of lightning, and that's basically just the electricity balancing itself out. So the lightning is the part you see. That's the flash, and it's hotter than the surface of the sun. Lightning is really, really hot, so you don't want to get struck by lightning. Thunder is what happens as lightning happens. Lightning warms up the column or the air right around it, and that causes essentially a shock wave. And so the air gets really big and then it gets really small again. And so you get the air masses or the air coming together. So you get a clap of thunder like that. And then that goes away from the lightning bolt. And you can tell roughly how far away you are from that lightning bolt by counting the number of seconds between the flash of lightning and when you hear the thunder. And then divide that number by 5, and that's how many miles away you are. So if you hear a lightning or you see lightning and then you hear thunder 5 seconds later, that flash of lightning was 1 mile away from you.
Excellent. So let me just give a real quick shout out to Miss G's class and Miss Pierce's class. Miss G's class is watching from Southwest Elementary, and Miss Pierce's class has just tweeted out that Spring Valley is on board and they're watching.
All right.
So thanks a lot, guys.
Hi,
We
guys.
really appreciate that. So, Grant, I just got a question from the YouTube channel, so people are watching on there too. And one of the questions is, why do pop-up storms pop up and then die down in the evening? What's going on with that?
Well, the atmosphere is, again, it's something that is always changing, and it's in a different state and in different places all over, not just the state of North Carolina, but all over the globe. And during the summertime, typically here in North Carolina, we have a decent amount of moisture. In the summertime, it can feel very humid. It feels sticky, and that's just all that water vapor in the atmosphere that makes it feel that way. And that's one ingredient that we need for thunderstorms, which is water vapor or water. Now, in the summertime, you also need heat to produce the thunderstorms, and heat rises in the atmosphere. So when we get into the afternoon, the heat reaches, or the temperature reaches that point to where the atmosphere is rising enough And I'm sure you guys have learned a little bit about the water cycle, where you have that evaporation, and then as you get to the point to where you've evaporated enough of that water, or you've created enough heat, then you start to have that condensation. And that's what begins to occur when you get a lot of heat in the atmosphere, you get a lot of rising, and it commences that water cycle. You get enough of that condensation, and then eventually, I'm sure you guys know, you get that precipitation. And then it starts to rain, or thunder and lightning, and it gets into those thunderstorms. Now, as we lose the heat of the day, which was that ingredient to start to spark those showers and storms, then you start to lose that lifting motion in the atmosphere, and then it sort of cuts the whole cycle off, and then everything begins to calm down again. So losing the heat of the day, really you lose that ingredient that you need for showers and storms to develop.
Excellent, thank you. So Kyle, I have another question from you, and this is coming from a classroom in Catawba County, actually. And their question is, that's my old county, who I adore these kids and students and their teachers, and they want to know, what can they do with all this knowledge once they get to college? If they don't want to be a meteorologist, what else is out there? And STEM is your alley. I know that you promote science, technology, engineering, and math in the classroom, so can you give them just a brief look at what they could do, maybe sit in your seat in 10 years and be on Weather Chat with us? So I'll let you take over from there.
What a great question, and the class that came up with that, I'm impressed. I think it's always worthwhile to think about, what do you really like? What kind of passions do you have? And then I think if you figure out what you love to do, then you'll be able to better figure out what you want to do when it comes to your life. And so there are so many things that you could do. I don't know if you've been paying close attention. I'm sure you probably have, but you've probably seen, even behind Grant, I'm sure there are tons of people that work with Grant every day that love the weather, but maybe they didn't want to be a meteorologist, for example. So you probably saw the camera guy behind Grant. There are so many people, especially when you think about sharing the weather and trying to let others know about what's happening, that even if you don't want to be a meteorologist, you could be a cameraman, you could be a director, you could be somebody that hosts events like this. I had the really cool opportunity to go down to the Weather Channel in December, and that's where I was mentioning being on a really neat event where we were talking about extreme weather and learning about it. And when I walked around those studios, it was so much more. The Weather Channel is so much more than just a few meteorologists. There were folks there that were editors, that were producers, they were writers. Writing was so important because they write about, hey, what do we want this show to tell, and what do we want, what story do we want to share here? So writers, engineers, to be able to put everything together and know the technologies needed, artists to be able to create the graphics and the visualizations. So I think the most important thing, there are so many opportunities out there, but the most important thing to consider if you're, and really when you're looking towards your future and saying, what do I want to do, is to figure out, what do you love to do? And I think passions and pages, and if you follow your passions, you'll find other people that are just as excited about those things that you love to learn about, and finding a career will be easy then, because you just fall right into the right opportunity.
All right. Thanks, Kyle. And just another quick shout out on Twitter, we have Miss Rutledge's class that's joining, and also Miss Poppy, Miss Harris, Miss Trich, Miss Schultz, and Miss Matson. I wanted to make sure to get those classes out, and we're all waving at you now, guys. I'm real proud that you're taking time to do this. Nate, another question from you, and we're almost finished. We'll just have a few more questions, and we'll wrap this up. And remember, this is going to be archived forever and ever and ever. So the internet never forgets. It does not. So if you miss our sweet faces, you can always come back to this. So the question is, how do you predict the weather? This is from Isaiah, and they want to know, what do you look at first, second, third, but in a real quick nutshell, how do you predict? What do you look at first when you're predicting weather?
Well, the first thing we always look at when predicting the weather is what's happening right now. So you can't, it's like trying to go on a long car trip and you get in the car and you pull out a map, or you want your GPS to tell you where to go, but to know where you want to go, you have to know where you are first. And so we try and understand what's happening right now. How hot is it? Where the wind's coming from? How much cloud cover? Is the sun out? That sort of thing. Always start with the current conditions. And then we'll look at climatology, which is what might be expected for this time of year. Is it typically warm or cold? Is it unusual for it to rain or snow? That sort of thing. And that can help us sort of focus our attention on the right things. And then we start to look at different computer models and try and figure out what the different computer models say about what the atmosphere is going to do. It's kind of like having a model car or a model airplane. In some ways, it looks and operates the same. In other ways, we've made some simplifications, and so the models don't always get it right. So what we have to do is know what goes into the computer models and what the models are good at and what they're not so good at, and then put them all together and use our knowledge of how the atmosphere works to sort of take all of that together and make a hypothesis or an educated guess about what the atmosphere is going to do tonight, tomorrow, this weekend, the next day, that sort of thing. And then, like we said earlier on, we have to go back after we make the forecast and see how we did. And did we do well? Did we get it right? And if we did, what did we learn? If we didn't get it right, what did we learn from that? And then we start the process all over again for the next day.
Thanks, Nate. And boys and girls, one thing that he said that they use models, and that's going to be a question that will probably show up on the end of grade test. So make sure you remember that Nate Johnson said that he uses models and looks at what's happening right now. So Grant, let me give you one more, and this is a big one too for us, and it's all about jet streams. So we try to remember that weather comes from west to east, because the first two letters in weather are WE, so that's my little mnemonic that I'm giving to them.
Nice.
So if we can talk about jet streams for just a moment, and then I'm going to let each of you sort of give us a final wish for these kids and what you want them to know, even beyond our testing.
Okay, so just asking about what is a jet stream?
Yes.
Okay. Well, a jet stream is basically just if you think about a highway, it's a current or a highway of very fast-moving air way up in the atmosphere, and it's called a jet stream because it's up where jets fly. It's very close to where, if you ever go on a vacation, maybe you fly out to California or you're flying down to Florida, you're going on a trip, those airplanes go very high and they get so high up into the atmosphere where they're up in this part of the atmosphere where you have these very fast-moving currents of air. And these fast-moving currents of air form because they are on that boundary, not at the surface, but again, really high up in the air, where you have a boundary between cooler air and relatively warmer air. And I actually was able to, I don't know if you guys will be able to see this, but I wanted to show you kind of what the jet stream looks like from one of our analysis tools that we use to analyze the jet stream. And can you guys see this right now?
Yes.
Yes.
Are you able to see it? So if you look here on the right-hand side of the screen is where you have North Carolina, and those colors there are indicating where the jet stream is currently moving. So it's moving out of the northern plains and moving to the south and east, and that's indicating that there is that cooler northwesterly to southeasterly flow coming our way that will be going into the weekend. And that's why you'll notice that compared to the last couple of days, it's actually going to be cooler because we have this fast-moving current of air that's going to be pulling down some cooler air for us as we go into the weekend.
Nice. Okay, so thank you for a graphic there. So Nate gave us a light bulb, and Grant gave us a graphic, and Kyle, is there a baby or anything yet? We have anything like that to show?
No baby yet.
So
tell them good TV is all about the props.
Yes. Yeah. So obviously we have not been able to hear from a few people that I had wanted to come in, but I do have a video, so I'm going to try to do this because I don't know how to share my laptop, my desktop, and when I tried it a minute ago, it didn't work. So I'm going to turn this up, and this is a message from Reed Timmer from the Storm Chasers, and he's shouting out to a couple of kids particularly, but I'm going to put him right here, so hang on, let's see if we can do it. I'll have to push play.
Say hi.
Hi, Molly and Katie. I'm Reed Timmer with Discovery Education here in Bozeman, Montana, 4 hours south of a confirmed tornado right now. So it's a very rare situation where I was standing here calm, enjoying the company. But there is a tornado, and probably lifted by now. But anyway, stay focused in school. Keep working on those STEM subjects because they'll pay off in spades someday. Definitely, no matter what field you're in, you never know, and math, science, and technology is going to help you out. Never stop chasing.
Excellent. So I'm going to now give you each just a minute or a few seconds to tell us what you would like to tell these 5th graders across the state. We know testing is a necessary evil and we have to do it, but we want to be able to pass this test so we can keep sharing our knowledge. So I'm going to start with Kyle. So Kyle, what would you say to these 5th graders that are learning so much about science and wanting to do well on the test, but also wanting to keep this knowledge inside of them so they can continue their careers in education?
I think my #1 tip would be to be observant. I think if you're observant and you're really paying close attention to the world around you, and then you're thinking about what things might mean, that you'll be able to figure out lots of these questions and answers on your own. A quick example, I'm not joining you from North Carolina this morning. I live in Pennsylvania. And in Pennsylvania, if you search the weather, I follow the weather all the time, we had some really rare storms called microcells, I believe they were called yesterday. And we had golf ball-sized hail and bigger. It was on the news all over the place because it broke car windshields and very unusual. And I wanted to know more about that. So just by being observant and looking around and hearing about this type of weather, then I thought to myself, how can I look and learn more about that? And I did a couple things, but you have the access to the power of the access to the internet to look things up. I know you all are learning and watching videos from Discovery Education streaming. We have Weather Channel videos in there you've probably already been seeing. So I try to be observant, and then I try to think, where can I go to learn more about that, and what do I need to know?
Excellent. So real quick, Miss Romanelli, I forgot to add that you were watching today, so thank you for watching via Twitter. Francie, I'm going to unmute you for a moment, and if you would mind giving my students here, 30 elementary schools, several thousand kids, a little good luck for the upcoming test.
Good luck on the test. We've already taken ours. We're with you in spirit, and just do what your teachers told you, follow the strategies, take your time, look over your work, and don't get stressed over it. You know this stuff. It's all good.
Nice. Thank you. So, Nate, I'll give it back to you for a second and give us some advice or some final words on weather.
Well, in terms of taking the test, I like to watch Jeopardy. It's my dream to be on Jeopardy one day, and won't happen anytime soon for reasons that, anyway. But I love to be on Jeopardy. But I think of tests as it's kind of like Jeopardy. You get to show off all the cool stuff that you've learned over the last year. And one of the ways to keep learning is keep asking questions. If something doesn't make sense, if you want to know how something works, find somebody to ask, or like Kyle was saying, you can go on the internet, find all kinds of videos. There's some great TV shows. Weather Channel does some really good stuff. Discovery does some really good stuff. There lots of good stuff out there for you to watch and to follow, and lots of great people that you can learn from out there as well. And so always, never stop being curious. So anybody tells you you're asking too many questions, no, you got to keep asking the questions. Find out what's happening. Always be inquisitive, and don't settle for not getting an answer. Everything out there is, that's the greatness of science, and how we use science in our world it's how we learn how our world works. And the more you know about how your world works, the better you are to be a part in it.
Thanks, Nate. That's great advice. So, Grant, we'll come to you.
Well, I have to say, just to give a little bit of background about me, I grew up and I was interested in many, many, many different things.
Mm-hmm.
I wanted to be a professional soccer player at one point in my life. Just like, every other boy out there, you want to be a professional athlete or something of that nature. And I really didn't get serious about science until I was older, but I always had a curiosity for life in general and what was going on in the world around me. And that was something that Nate touched on there is, there are so many things that we don't know about the world around us, not just in the weather world, but in the world of science, in the world of the environment, and in just everything around us. So if you have a curiosity, definitely seek out that curiosity, and you will find a way to have that be a part of your life, whether that's a career or some sort of hobby. It's always good to fulfill yourself through that. And it came to a point where I grew up in Michigan, and we have a lot of different weather up there, from strong winter storms to intense severe weather in the summertime. And the reason I got into meteorology was because I was always curious as to what is going on in my backyard. What is this crazy thunderstorm that keeps rolling out of the west, and how does that happen? Why is the cloud darker when the storms come in, and why does lightning create thunder? And there's a lot of things that you can learn about through just a curiosity. And it got to the point to where I chose to go down the meteorology track, and the broadcast meteorology track for that matter, because I like to share that information. I like to be a part of that learning process, because if you go into science, you're never going to stop learning. And as you take these tests, just know that you have learned everything already.
Yep.
And now you just get to prove it. So,
Yeah.
Something that it should be a lot of fun, and it will be if you just keep on, taking it day by day.
All right, thank you so much. I do want to say that Nick McGuire was going to join us from Kiel, England, and we're having some internet issues, but he sends his best and will give us an update on the weather a little bit later. I do want to tell the students out there that Nate and Grant and Kyle did not charge me for this. When I put out a tweet about getting some weather experts, they immediately said absolutely. They jumped on it very quickly. So we want to thank them today for their ability just to drop what they're doing, even while their wives are having children, and come and be with us. We're very excited about that. I do want to encourage you, boys and girls, to keep studying and keep learning, and you can do this. We are very, very proud of you, and I think it's going to be a great end of the year, and we hope that we can do this again. I do want to thank those of you out there that were not watching from Durham Public Schools, and I do want to put a plug in. Talk with your science teachers. If you guys are not using Discovery Education in your district, you absolutely need to get on that. Most of the learning that's happening with our kids is we're using a lot of Discovery Education textbook information, lessons, streaming, and that's just a real important key to making sure we have a lot of stuff to support our children in the classroom. So thanks, Nate, and thanks, Kyle, and thanks, Grant, and to my kids in Sarasota Springs, Florida. We are so glad that you were here today. And students, if it's time to go to lunch, go. Okay, so go to lunch, and you guys can go to lunch too, and thank you very much, and everyone wave, and we hope that we'll do DPS Weather Chat 2 next year. So thanks a lot, guys, and I'm going to stop the broadcast.